Picture a soaring skyscraper, its beams reaching towards the clouds. This marvel of engineering, like countless structures around us, owes its existence to one remarkable material: steel. From the utensils in your kitchen to the device you're using, steel silently shapes our world. But how did we unlock the secrets of this metal, transforming it from simple iron into the backbone of modern civilization? Join us on a journey through time as we explore the evolution of steelmaking, uncovering the challenges faced by ancient metallurgists and revealing how their ingenious solutions paved the way for the advanced alloys we rely on today. Picture this. It's 1500 BCE, and a metalworker in ancient Anatolia is carefully tending to a blazing furnace. As they sift through the cooled remnants of their latest smelt, they notice something unusual: a piece of metal unlike any they've seen before. It's stronger, more flexible, and holds an edge better than the bronze they're accustomed to working with. Little do they know they've just stumbled upon the beginnings of steel. This accidental discovery set humanity on a path of metallurgical exploration spanning millennia. Early metalworkers grappled with a material that seemed to have endless potential, yet proved frustratingly difficult to control. The key lay in the delicate balance between iron and carbon, but without modern scientific understanding, achieving consistent results was a monumental challenge. As civilizations experimented with this new material, different techniques emerged. The bloomery furnace allowed metalworkers to produce small quantities of workable iron, but the process was labor-intensive and often resulted in varying carbon content. It was like trying to bake the perfect loaf of bread without knowing the exact ingredients or oven temperature. Sometimes you'd get a masterpiece, other times a disaster. Despite these challenges, steel's superior strength and durability made it ideal for various applications. From the legendary Damascus steel swords to the meticulously folded katanas of Japan, each culture developed its unique approach. Steel was used not only for weapons and tools, but also for creating intricate jewelry, religious artifacts, and advanced agricultural implements. Yet for all these advancements, the fundamental limitations of ancient steelmaking techniques remained. The process was slow, yielding relatively small amounts of steel at a time. As empires expanded and trade routes lengthened, the demand for steel began to outpace the ability to produce it using traditional methods. What made steel so desirable, and why was it so challenging to perfect? The answer lies in its unique properties. Steel combines the strength of iron with the hardness imparted by carbon. When heated and cooled correctly, the carbon atoms integrate into the iron's crystal structure, creating a material stronger than either element alone. As we leave the ancient world behind, the stage is set for a revolution in steelmaking. The growing demands of expanding empires and nascent industries call for new solutions. Who will crack the code of mass steel production? And how will this breakthrough reshape the world as we know it? As the Industrial Revolution surged forward, a critical challenge emerged: the world's insatiable demand for steel. Traditional methods like puddling and cementation were painfully slow, taking days to produce a single batch of steel ingots. This bottleneck threatened to stall progress across industries, from construction to transportation. Enter Henry Bessemer, a British inventor who would revolutionize steel production. In 1856, he introduced the Bessemer converter, a pear-shaped vessel that could transform molten pig iron into high-quality steel in minutes. The key to this process was surprisingly simple: air. By blowing air through the molten iron, Bessemer oxidized impurities and reduced carbon content, creating steel faster than ever before. The impact was immediate and profound. What once took days now took about 20 minutes. This dramatic leap in efficiency promised to meet the escalating demands of the Industrial Revolution. However, skepticism abounded. Many metallurgists doubted that such a simple process could consistently produce high-quality steel. To appreciate the revolutionary nature of Bessemer's innovation, consider the contemporary methods. While more efficient than older techniques, they still required significant time to produce a batch of steel. The Bessemer process, by comparison, was lightning fast. As technical challenges were overcome, the true potential of the Bessemer process emerged. Between 1867 and 1884, the cost of steel rail dropped by more than 80%. This price reduction unleashed a wave of transformation across society. Suddenly, steel became accessible for a wide range of applications. Buildings reached unprecedented heights, changing city skylines forever. The expansion of railways accelerated, connecting distant communities and boosting trade. Even everyday items became more affordable and durable. However, the Bessemer process wasn't without its limitations. It required specific types of iron ore, and controlling the final carbon content proved challenging. One significant hurdle was the need for low-phosphorus pig iron, which was more expensive and less available. The introduction of Spiegeleisen, an iron alloy containing manganese, helped address some of these initial shortcomings. But what other challenges did the process face, and how would they be addressed? We'll explore that in our next segment. Picture a modern steel plant, a colossal structure of gleaming metal and towering furnaces where the air hums with energy and the ground trembles with power. This is where the basic oxygen furnace and electric arc furnace reign supreme, producing over 80% of the world's steel. The basic oxygen furnace process is a marvel of efficiency. It combines molten pig iron and scrap metal, then blasts pure oxygen into the mix. This creates temperatures so high and reactions so fast that a batch of steel is ready in just 20 minutes. The result? Higher quality steel produced faster than ever before. But the electric arc furnace is the rising star in steel production. It can create steel from 100% scrap metal, making it an environmentally friendly powerhouse. Imagine electrodes dancing with electric arcs, generating heat hotter than the sun's surface. This incredible furnace doesn't just recycle metal, it transforms it into high-quality steel for everything from buildings to bridges. Modern steelmaking is as much about precision as it is about power. Today's metallurgists are creating specialized alloys that push the boundaries of what's possible. These custom alloys are tailored for specific applications, from skyscrapers to surgical instruments, each with unique properties that make them perfect for their intended use. The environmental impact of steel production is a pressing concern. The industry, once known for smoke-belching furnaces, is now at the forefront of the fight against climate change. Electric arc furnaces, especially when powered by renewable energy, produce significantly fewer emissions than traditional methods. Some companies are even experimenting with hydrogen-based reduction processes, which could potentially eliminate carbon emissions entirely. Looking to the future, innovations like the hydrogen reduction method promise to revolutionize steel production once again. This process aims to replace carbon-based materials with hydrogen gas in the reduction of iron ore, producing water vapor as its primary byproduct instead of carbon dioxide. As we continue to build our world with steel, these advancements will ensure that this vital industry remains strong, sustainable, and ready for whatever challenges the future may bring. From ancient forges to modern skyscrapers, steel has been the backbone of human progress. This versatile metal, responsible for 8% of global carbon dioxide emissions, embodies both our greatest achievements and challenges. As we stand at a crossroads, engineers and scientists are forging new paths to sustainable steel production, much like Bessemer revolutionized the industry in the past. The next chapter of steel's story is unfolding, promising to be as transformative as ever. Like a hero adapting to new trials, steel continues to evolve, meeting the needs of our changing world while embodying the spirit of human ingenuity.